Greetings everyone and welcome to this video on effect size and location parameter. Until now, we have been concerned with the p-value and whether to accept or reject a hypothesis based on the absolute value. Hence, the p-value will inform us whether the effect exists. However, just by looking at a p-value of say 0.05, 0.01 or 0.0001, we will still not get an idea of the extent of change that the effect or an intervention has made. That is to say, we don't get an idea of the magnitude of the change. To quantify this magnitude, we use a measure known as effect size. There are different measures of effect size such as the Cohen's d, Glass's delta, Hedges' g, rank biserial correlation, eta squared, and so on and so forth. To illustrate the concept of effect size better, we will consider an example. We will consider this data set. This data set provides us with information of two groups of students, one group of students who were treated, so to say, with reading activities and one who served as controls. After the reading activities, a reading test was administered and the scores are given in this column. We will check the adequacy of the null hypothesis that reading activities do not have an effect on reading scores. To do that, we will use the independent samples t-test. We will check for normality and equality of variances. There seems to be no problem. And we get a p-value of 0.029. After obtaining some descriptives, we can see that the treatment group scored 10 points better than the control group. Now, what actually is the effect? What actually did this reading activity do in terms of improving the scores? How much of an effect? Can we quantify this magnitude? So, this can be quantified with the help of effect size. To check that, you can select on this checkbox, and Cohen's d is the most popular. You can also select on confidence intervals to get 95% confidence intervals for Cohen's d. So now Cohen's d can be used to gauge the effect size in many statistical tests, such as the independent samples t-test right now. Arbitrarily, when we get a Cohen's d value of 0.2 or minus 0.2 to 0.5 or minus 0.5, the sign does not matter. We can consider it to be a small to medium effect size. When it is between 0.5 to 0.8, we can consider it to be a medium to large effect size. And when it is more than 0.8, that's when the effect size is large. In this case, we get a p-value, we get a Cohen's d of 0.6. Do not consider this sign. So 0.68, which means this is quite a large, medium to large effect size. So the reading activities did have quite a large effect on reading scores. If we get a p-value, if we had gotten a p-value of 0.047 and the Cohen's d value was 0.1, even though we accept the alternative hypothesis and agree that there is an effect, the effect size is still not very large. The Cohen's d is just 0.1. On the other hand, if we get a p-value of 0.024 and the Cohen's d is 0.6, we would still accept the alternative hypothesis just like the previous example, but the major difference is that the effect of the intervention or change was significantly more than the first effect or the first change or intervention. So this is the significance of the effect size. Now, a location parameter for a data distribution is the typical or central value that best describes the data. Common location parameters include the mean difference, standard error difference, Hodges-Lehmann estimates, and so on. The mean difference is exactly what it looks like, sounds like. It is the difference of the two means of the data groups. The standard error is simply the standard deviation of the sampling distribution. or in terms of equations, it is the standard deviation divided by the square root of the sample size. To get a location parameter, we can select this checkbox with confidence intervals if you wish. And here we have mean difference and standard error difference. We get a mean difference of approximately 10, which is something we saw previously right here, approximately difference of 10. And of course, 95% confidence interval. And of course, we can also check for the standard error difference. So that's it for this video. Thanks for watching, and I'll see you in the next video.